In this video, we're going to review the idea of what the domain and the range are for the function. So first, when we're dealing with domain, what that's talking about is all the x values or the inputs of a function, and then the range is dealing with all the y values of a function or the outputs. Okay, so when we look at number one, we have a set of 4 points. So that's all that we have in this relation. So we first want to find out what our domain is, what our range is, and then we're going to answer the question of whether it is a function or not. So before we even start that, since we're dealing with points, we have to remember that every coordinate pair is talking about an x and a y. So if we're looking at the domain is dealing with our x values or the first number in our point. So if I look at all those ones, I'm just going to underline them right now in purple. Those 4 numbers are our domain. Okay, so I'm going to write those out in a set as well. So we have 1, 2, 4, and 6. Then if we look at our range or our y values, that's all the second part of our function. So that's all these that I'm going to do a little squiggle underline here in red. Okay, so those numbers are the range or the y values. So I can write those down in a set. So 2, 5, -1, oh, and 2 again. So I'm not going to list it again, just those 3 numbers. So then we've got to answer the question, is it a function? So what makes something a function? That's what we have to remember. Okay, so a quick little definition of what makes a function a function. Every input can only have one output. Okay, so that's what makes it a function. So every x only has one y. Okay, that's really what that's saying. So if I look at this and I go back to my x's, 1 goes to 2, 2 goes to 5, 4 goes to -1, and 6 goes to 2. Every single x is different and it goes to a y, so that means that it is a function. What sometimes people like to say is that the x's don't repeat. It's a good way to just check a list of points like that. Okay, so then if we look at the second example, now we have what's called a mapping, where it's taking each element of the first oval and going to something in the second oval. And it's even labeled very nicely for us as domain and range. Sometimes they label these as x and y, but they were really nice to us in this problem. So if we've got to look for the domain's just that first oval. It's 3 numbers. So I'm going to list those out in a set again. So -4, 0, and 6. Our range, well, that's the numbers in the range oval. So those 3 numbers, 12, 18, and 40. So now we've got to decide, is it a function or not? So every domain element or every input can only go to one output. So if we follow each one of these arrows, -4 goes to 18, 0 goes to 40. 6 goes to 12, but 6 also goes to 18. So 6 is repeating. It has 2 outputs. So this is not a function. Okay, so just checking to see what happens. That 6 is going to 2 different numbers in that range. So that's what makes it not a function. The last thing we're going to look at, and this tends to be the one that we have a little bit more trouble with, especially when we looked at our test on functions. This is a question that we struggled with a little bit. So it's finding the domain and range from a graph. Okay, so domain, we're still looking at the x's. Okay, so we have our x-axis here. So the x-axis goes left and right. So we want to see how far over does our graph go to the left, and it starts at this point right here. Then it goes up and down and all the way around, and it stops at this point. So our graph or our domain is in between here and here, almost like if we could squish it. That's the only part of the window that we would look at. So where it starts, we just got to figure out what value that is. So if I start at 0, 0, I'm going to -1, -2, -3, -4, -5. And then where it would stop at 1, 2, 3, 4. So our domain, it's all the numbers in between -5 and 4. We can't list all those out because it's not just the nice integers on there, it's all these other in-between points. So we're going to write them as an interval. So when we write as an interval, we always start with the smaller number. So in this case, -5 would be less than or equal to, we're dealing with domain, so we're going to put our x there, then our less than or equal to 4. Our range is the same sort of idea, except for this time, we're going to be looking up and down. It's how low does our graph go and how high does it go. So if we follow our graph along, this is our lowest point down here. This is our highest point up here at the end. This lowest point we would call our minimum, where this point up here, this would be called the maximum. So when we're dealing with the range, we're looking at how high and how low does our graph go. So we're looking at that y-axis now. So almost like if we could smush it on either side. So then we just need to know those numbers. Okay, so our range is dealing with y, so we need to know what y values those are at. So my minimum was at -1, 2, 3, 4, 5, so -5. My maximum is at 1, 2, 3, 4, 5. So when I write my interval this time, I would start it with -5, that's my smaller number, is less than or equal to y this time, which is less than or equal to 5, which is my bigger end of that range. The last part of this is we have to decide if it is a function or not. So when we have a graph, there's a nice test that we can do. We could use what's called the vertical line test. So the vertical line test is a way that we can see if every input only has one output. And what it says, if I draw a vertical line anywhere through my graph, it should only hit the graph one time. If it only hits one time, that means it's a function. If it hits more than one time, it is not a function and fails the vertical line test. So no matter where I draw a vertical line, it's only going to cross my function one time. So that means that this one is a function. I hope that this review of finding the domain and range of a function was helpful and that you guys were able to refresh from this. Okay? Thanks.